This is the tech team from Ericsson Robotics, which is made up of Travis Veach, Kalkin Gupta, Sanjana Kishore, Veda Kutagala, Shreya Nair, and Tejas Ram. Our job is to program the robot using Simulink, which is a product of MATLAB. Simulink is a graphical programming environment that allows you to drag and drop blocks. It roughly translates to C/C++.
This is the drive system that controls the robot's horizontal movement on the rail. The motion of the robot is controlled by two factors, the position of the joystick and whether the 5-down button is pressed or not. The robot moves in the direction the joystick is pushed. The 5-down button reverses the motion of the robot in relation to the position of the joystick in order to compensate for the robot being on either side of the field. This function makes it easier for the driver.
This is the state flow diagram for the drive system that controls the basic movements of the robot. We added this feature to make driving easier for the drivers, regardless of what side of the field they're located. A dead zone was added to prevent unintentional movement of the robot up and down the rail.
This is our program for the arm's vertical movements. The motion of the arm is controlled by the Y value of the joystick. When the joystick is pushed in an upwards direction, the arm will move up at the rate of Y, which is the value of how far the joystick is pushed. When pushed in a downwards direction, the arm will move down at a value of Y, which will be the negative value. The arm moves in the direction that the joystick is pushed. A dead zone was added to prevent any accidental movement of the arm. The buttons control the horizontal motion of the arm in order to reach the gyres to collect plastic. If the 8 up button is pressed, the motor spins forward and causes the arm to extend outwards. If the 8 down button is pressed, then the motor spins backwards and causes the arm to extend inwards. This is our state flow chart that controls the arm's horizontal movement. When the button A is pressed, the arm moves upwards. When the button B is pressed, the arm moves downwards. When both buttons are not pressed, the arm doesn't move at all.
This is a program that controls the flap behind the cloth, making sure that the trash collected does not slip out. Both buttons control the movement of the motor for the scoop. If the 6 up button is pressed, then the motor spins forward. If the 6 down button is pressed, then the motor spins backward. This is the state flow chart for the scoop. When the button A is pressed, the scoop flap closes, keeping the trash in the scoop. When the button B is pressed, the scoop flap opens, releasing the trash. When both buttons are not pressed, the scoop is still.
Thanks for viewing our Simulink design video for the Best 2018 competition. Make sure to support Ericsson Middle School this year.